Good morning, students. Today we are having a discussion regarding Hplc, how it has been used in standardization of herbal drugs and herbs. So you see, when you want to go for Hplc is a very important instrument. You might have studied in detail in your previous semester, and also you might have come across the instrument detailed in analytical instrumental methods. So anyhow, I cannot leave it just so I cannot leave the instrumentation part also, but I am just going little faster and with explanation, which that's why. But still, because when you want to know about what is a column which is used and whether it is what type of gradient method used when they are giving in the column, solvent system and the detector nanometers when they are giving for some herbal samples which they have done, when you want to write in your examination paper, the student should have a perfect knowledge of background about all these things, and so that it will be easy. Even I have incorporated video from Dr. Sheetal from B.Y. Patel Institute of Pharmaceutical Sciences, Pune. She has given a very good, marvelous explanation. So that's why even I have not even stopped her audio. Even if you listen to her, she was having a very good language, an amazing explanation in a short manner. So that will be very nice for you to know about the instrument which is present in our institution also. You can go and observe and so that it will be more easy for you to write the exam. So now we will see high performance liquid chromatography, and it's about the instrumentation little faster. What do you know? So the technique is high performance liquid chromatography is called because it improves performance when compared to a classical column chromatography. So why I want to compare here classical column chromatography, because I remember my professor who came from JSS OT, and he came with an examiner and I was co-examiner with him. He is professor for me also, Dr. Ravi Shankar, Professor Ravi Shankar. His book, I just took, it was very long back, and it was so nicely he has explained, very simply he has explained it, and it was very amazing book which he has written and he has published. So anyhow, we will remember him because we should remember the prime person who have done anything. When you are copying something from other person, we should respect them and we should remember them and how they made us to, because knowledge can be transferred from one person to another, but we should not forget from where we got the knowledge. That's why I remember him. Now, I have said thank you. And now you can see this class. That's why he has compared in his book, first to know about the classical column and the Hplc column. What is the difference in their size and why it is called high performance liquid chromatography. Why we want to say Hplc from the normal column, that he has explained very clearly. So this high pressure is also used in the liquid chromatography, and why we want to use when compared to classical column. And the development of Hplc is from the classical column attributed development of smaller particle size. Particle size plays a major role, important, since it is more surface area will be increased. You might have studied in pharmaceutics. So I'm not going back to explain all the things, but you can remember it is surface area will be increased so that the separation can be done very feasibly and very fast, and also very wide range, and also very performance and perfect can be done. So 5 micron offers in Hplc. And so that you can see theoretical plates are very high when compared to normal column. Theoretical plates means the imaginary plates, and which is the number of theoretical plates is minimum 2000 for any HPLC, but it can be in HPLC you can see that it is more than 100,000, that means 1 lakh, more than 1 lakh of theoretical plates can be possible. But at the same time, when you come to the normal column, it may not be having that much theoretical plates will be seen. Maximum of it can be somewhat below maximum of 1000 or maximum of sometimes 400 to 600, 700 may be available theoretical plates. Even though the column are very big, but you can see that the particle size which you are using in the normal column chromatography, which is very high, so you cannot get more theoretical plates or more perfect or performance. That's why the performance need. This is a comparison which Sir have given in his book. You can see here, he has given very clearly in that the classical column is very large, and 60 to 200 microns, and also you can see the size of the micron size, the particle size is 60 to 200 micrometer or micron you can say, and you can see HPLC is 3 to 20 micron. So very very small particle size, that's why surface area is more, and the column is also large in the classical column and small in the HPLC column. And the glass, it's made up of glass, and here it is made up of metal, and sometimes we are nowadays using hard plastics and some metals also. It is very much needed because we are using more pressure, and also it is short column. You see the size of the column, and this pressure, the flow rates of the movement of the mobile phases are low speed in the classical column, but in the HPLC column it is very high, and the low efficiency when you see it is less than 500 theoretical plates. Even I told up to 2000, but 500. But you can see here more than 1 lakh or 100,000 theoretical plates can be seen, and detectors, very large amount of detectors, and the amount high efficiency detectors are used in HPLC. And you can see in detector cell volume also you can see there is, and it's a small volume in HPLC, and it's having preparative method in the column, large quantities. But if we see in HPLC, analytical and preparative. Analytical and preparative, that means if you want to recover the sample, and large quantity of samples can also be analyzed in HPLC. At the same time, it is a small quantities like analytical methods can also be followed. So you can see the basic techniques in HPLC which all can be, you might have studied according to the basic techniques, how they are differentiated different types by based on the mode of the chromatography. Mainly you should note that we are using always reverse phase chromatography. The student should know what is normal phase chromatography and reverse phase chromatography in HPLC. That is why I took this lecture along with your previous classes, what you studied also. I want to make you clear in this situation. So that's why that is the main reason. So based on the mode of the chromatography, based on the principle of separation, what is the principle? Mode means reverse phase, normal phase. Based on the principle means there are various principles you might have studied: absorption chromatography, partition chromatography, and gel permeation chromatography, affinity chromatography, and you might have studied about even various other chromatographies like gas, that is, for example, that is also partition which works, and also in gel permeation chromatography, and there is various types of principle which can also followed in even ion exchange chromatographies can also be followed in HPLC by means of just changing the column, and also different columns are available by means of the stationary phase changing. It is possible, and based on the eluting technique also it is possible. What do you mean by eluting technique? When you come to the eluting technique, you can go for whether you are doing isocratic technique or you are doing gradient technique. So gradient, isocratic, a same solvent system is completely run in the column or run in the experiment with the same type of polarity, with the 2 mixtures or 3 mixtures. But at the same time, gradient every time, every minute, or you can every consequent minutes, or you can just make manually for 5 minutes later or 10 minutes later according to the gradually you can change the solvent system, mix the solvent system. Percentage of polarity can be changed in the whole experiment. So the gradient changing is also possible for various separation of the compound. If there is a lot of mixtures are present, it is possible for grades. Usually we prefer the gradient type of experiments. So it can be, for example, I am telling about only two solvent system example. If I want to say an example of two solvent system, if you are having two solvent system, one is 80 and one is 20, if you are mixing, after 2 minutes this 80 may be going to 60 and the other one will be 40. So like that, and after 5 minutes this 60 may become 40 and the 40 which you use the B solvent may become 60. So the polarities of the solvent system which is moving through the column in the HPLC can be changed by means of this gradient method. So that is what elution technique, and based on the scale of operation by means of whether it is an analytical scale or you are going for any type of preparatory scale, that means amount of you want to go for analytical size means very small, the scale of operation can be done. And also type of analysis, like whether it is a qualitative analysis or quantitative analysis, like that analysis of type of analysis can also differentiate in the various techniques. So these five things are necessary for you to know about HPLC, which can be going for application for the herbal drug technology. And herbal drug that when you want to analyze with the using of HPLC, you should know this type of things can also be followed in HPLC. So based on the mode of the HPLC, two modes as I told, normal phase mode and reverse phase mode. The mode are based on the polarity of the stationary phase and the mobile phase. Before explaining the mode, it is important to know the interaction between solute and the stationary and the mobile phase is very important. So polar and polar interaction or affinity is more for polar, and non-polar interaction and affinity is less. So you see, normally all the drugs and also herbal drugs we are having water soluble drugs are more. So we prefer reverse phase chromatography. Reverse phase chromatography, because the normal phase chromatography, the aqueous soluble or aqueous loving hydrophilic components will be staying for the stationary phase in the column for a long time, and it retains, the retention time will be very much delayed and the separation will be difficult. So we prefer always reverse phase chromatography for drug analysis and also for herbal drug standardization. So hence the two hold whether the interaction between the solute or stationary phase or a solute and the mobile phase. So normal phase, which I want to explain, is normal phase mode. A stationary phase is like silica gel. They are polar in nature, and the mobile phase will be non-polar. So the technique is non-polar components travel faster, and the polar components will stay for a longer period. So these type of things can be, therefore the compound which is retained in for a longer time and in the column because of the affinity towards the stationary phase. So you can see that this is a disadvantage, or it is not advantageous for pharmaceutical application, since almost all the drug molecules are polar in nature and takes longer time to elute and to detect. So hence the technique is not widely used in pharmacy, and you can see reverse phase for mode is more useful, and non-polar will be the stationary phase which is used, and the polar components will be first eluted very faster, and so that when you are having. So what type of polar stationary phase which is preferred for the HPLC? Just simply what I want to say, octodilsilane. That is, there are many columns are there, but still you should remember the name of octodilsilane. And C13, C18, C6, C4 and etc. are available. ODS, don't forget about telling about the reverse phase mode of chromatography, which is more commonly used for pharmacy. And based on the principle, you can go for adsorption, partition, ion exchange chromatography, ion pair chromatography, size exclusion chromatography, gel permeation chromatography, affinity chromatography, even chiral or chiral phase chromatography can be also one. Chiral or chiral, whatever your pronunciation, you can just take it as consideration. The isomers can also be easily identified by means of this phase chromatography, by means of changing the column. So that is what we want to say about this And then first when we talk about adsorption and partition chromatography, which you know very well, and it gives affinity compounds towards the stationary phase by means of separation, normal phase as well as reverse phase, but we prefer the reverse phase chromatography. In partition chromatography, we should know about the reverse phase chromatography. It's very important for you to know about the stationary phase. Packing material replaced by silica by a polar phase of chemically bonded with silane, and also you can see lacroshope diols, and also very small micron, that is for example bond pack CN is also available, and you can see polysil NH2 also available. And in order to increase the polarity of their diols or cyanoamino, this type of chromatography is which the mobile phase is the polar, then this less polar, not polar, less polar than the stationary phase, and this is called the normal phase partition chromatography. But when you come to reverse phase chromatography, we can go for relatively polarity of Hplc, which you are using stationary phase with that is for example when you are SiO(Si), which is linkage, we can say silane is engaged, and Ceylon, that is Selenol usually. So when you see there is octodiol untreated, Selenol groups may be capped in treating with the trimethyl chlorosilane to eliminate the absorption effect. So this is only simply you should know about the what you studied previously. It is needed for you to know about, revise your basic knowledge in Hplc. That's why I'm just giving here a fast explanation for that. You should go for many chapters in our quality control and standardization of herbal drugs. So this the mobile phase in reverse phase chromatography, water and as less polar organic solvents modifier like methanol or acetonitrile. Usually acetonitrile we are using it for various solvent system in chromatography, in reverse phase chromatography, in Hplc. So in different degrees of hydrophobicity of the solute, the separation can be take place, and the less polar solute partition at a greater extent in the non-polar solvent phase, and consequently being retained on the column longer than the more polar solutes. That's, we know that very clearly, but you should read it, and so that you should mention it, so that it will be easy for you to get more mark. And also you can see using acetonitrile instead of methanol is one of the things which they have followed in reverse phase chromatography of in Hplc. So when you now we are coming to about the flow rates also and eluting. These all are some of the parameters which you should know, very important, because flow rates, what is the pressure you are using, what is the how much ml per minute you are allowing to pass through the stationary phase is also they are given in the tabular column of an example of herbal drug standardization. Ion exchange chromatography, ions, there are anions, cation exchanges which can be also used for in the chromatography for your separation, and ion pair chromatography, example of pentane, hexane, heptane, octo, sulfonic acid, sodium salts, tetramethyl ammonium hydroxide. These all can also be followed in Hplc because we are just coming to the stage of what type of Hplc can be followed by its principle. And then you can see size exclusion or gel permeation chromatography is also possible, where you should remember according to the molecular size, molecular sieve, a different molecular size by means of that which we can differentiate it. Remember what is a compound like dextran, agarose and polyacrylamide are used as a stationary phase which can act as a gel permeation chromatography in Hplc. It can also be followed as changing the column. And rigid gels like polystyrene, alkyl dextrin, non-aqueous medium also can be used in certain cases, and steric and diffusion effects are the main separation takes place here. And also you can see there is affinity chromatography, affinity of the sample by means of finding out special stationary phases can be designed according to the specific character and affinity. It can be used in many biotechnology, microbiology and biochemistry, it is possible for them to use this type of technique, and this affinity chromatography can also be followed in HPLC. Chiral or chiral phase chromatography can also be followed, separation of optical isomers and be done by using chiral, and stationary phases, according to that we can select and operate different types of stationary phase and different samples can be incorporated. Mostly high chemical bonding silica gels are used in this chiral stationary phases or chiral phase chromatography. So now the third one is coming to the based on the elution technique. By elution technique, it's very important for the students in this junction. You should mention in you, and even you are writing the question, what is the application of the Hplc for herbal drug technology for standardization. It's necessary for you to know about what is isoplatic separation and gradient separation. As I told, isoplatic, in this technique, the same mobile phase combination, maybe one or two, is used throughout the experiment. If it is 20 minutes experiment or 10 minutes experiment, throughout the experiment, the same solvent system, same mobile combination, same solvent system, same polarity, or say it can be used throughout the process of separation. The same polarity or the elution strength is maintained throughout the process. But in the gradient, in this technique, a mobile phase combination is lower polarity or elution strength is followed by gradiently increasing the polarity and eluting strength. As I told, if there is 2 or 3, if it is 2, if it is an example, one is 60 and then is 40, you are using the increasing the polarity, polar compound, and next after 10 minutes, after 2 minutes, immediately you can manually, you can change or you can give the feedback in the, you can feed in the computer, and automatically it can also be changed. It means the 60 will become 40 and the 40 will become 60. Or 60 will become 30 and the 40 will become 70. Like that, the ratio by 5:5 or 10:10 or 2:2, even 1:1, the ratio can be gradiently. You can change the concentration, the concentration or the amount of the solvent system, and also increase the polarity, decrease the polarity can be done, and the gradient method is followed throughout the experiment. Based on the scale of operation, as I told, analytical or proprietary. Analytical in a small quantity, sometimes it is also recovered, but usually recovery of the samples are reusing normally not done because if the quantity is very less. And preparative, you need the sample, you are separating the sample, you are taking out the sample. So that is called the preparative HPLC, where the individual fractions, pure compounds can be collected. Using fractional collection, the collected samples are reused and can be few grams of mixes by the HPLC. And based on type of analysis, whether it is qualitative analysis or quantitative analysis, qualitative means you may be doing identification of the compound, presence, the impurities, and the number of compounds, etc. can be identified. But quantitative estimations, which is done by the determination of the quantity of the individual by means of comparing with a reference sample and or comparing with the peak of the standard of the sample can be also done. So based on analysis. So this is what we have discussed now. Just I want to remember because I want to go for a little faster. What is the technique can be followed. So based on what are the types of HPLC which we have seen is based on the mode of the chromatography, based on the principle of separation, based on the exclusion technique, and based on the scale of operation, based on type of analysis. This is the basic HPLC needed. You need that these things should be explained clearly. And suppose if they are asking an essay question or a 5-mark question, you should have at least an idea to explain that this type of HPLC types can be done. In this all parameters can also having influence. And now we are going to the instruments. It is very important. Pump is very important because pressure is used in how the pumping of the stationary phase is moved through the column and the solvent delivery system. And in this that is called solvent delivery system. And also mixing of unit gradient controller. Like as I told 60-40, 40-60 or 30-70. Like that every minute if you want to change means there should be a gradient controller, and the solvent degassing is very important. Gases are not allowed to present in the solvent system because it will crack the column and it will completely spoil your chromatogram which is obtained. So that's why degassing is also very important. By degassing they used to use by means of helium. It's costly, but they used to use by purging method is also possible for them by means of ultraviolet. So sonication can also be done And these all things can also remove the gases which may be present in the liquids which is moving as a stationary phase can be removed. Injection spot, manual spots are there and auto injectors are there, and there is injector which is called rheodine injector is a very important loop injector which we will see. That is even the madam which is explaining in this video, she was explaining very clearly about the injecting spot, and it was very nice, very interesting for a person to see about the lab in this, especially in the virtual type of classes. It's very interesting to see the video, one who is explaining very interestingly, very simple explanation which is given by Dr. Siri. And you can see God column is there, analytical column is there. God column is not having any separation of the samples which you are injecting. We are not injecting in the God column. God column is only present inside the instrument just to purify the solvent system which you are using it. Just to remove the impurities or debris or impurities other than any type of impurities which may be present in the column can be removed by the God column. An analytical column is the column which where there you are injecting the sample and you are getting the separation, and it gives a separating analytical column. It is small and it is very costly, and also it should be very sensitive column which has to be kept in there. It's a short column, as you tell, maybe about 30 centimeter or 40 centimeter. Nowadays you will see ultra Hplc, that is ultra high performance liquid chromatography. You can see very short column, and the particle sizes are very small, even 1 micron and less than 1 micron sizes are also available, which gives more specific and a more efficient separation can be also done by Hplc, that means ultra Hplc or ultra high performance liquid chromatography. And then you can see detectors. There are many detectors which you have to see, you have to study, but we are using that is UV detector or UV detectors. UV visible detectors are very commonly used and fixed in the most of the companies now, because it has more efficient and most wide range of detection of the compounds. And recorder and integrator is now changed by means of computer. And you can see this is the schematic diagram of the solvent system which can be kept as, and it can be pumped, injected, and the column and detector and the waste we did not show, and the computer which is connected. And we did not mention about the God column. God column will be there before the analytical column, which can be used for removing the impurities which may be present in the solvent system. And pump solvent delivery, as I told that this pump it has to be having 5 to 10 micron stationary phase sizes, particle size. The resistance will be where solvent is high, and also that is why you need high pressure of 1000 to 3000 psi, and the high pressure is recommended for with a pump of pneumatic pumps. Usually they are preferred, and there are many pumps are also available, piston type, mechanical type pumps are also available, but still the pneumatic type is recommended for automatic system of pumping. And also it has to be controlled, and the purity preference by means of check valves are needed. The flow rate should be controlled. These all things you might have seen very clearly in the instrumentation. I'm just giving you some of the points to remember. And the pulse dampers also very important. How to the pulsative damper, it may cause wavy baseline is not possible. So we have to discuss the pumps when there is something. Pumps are not having any type of, if there is a pulsative pumps and there is a dampness should be kept there for making the baseline straight. And the mixing unit, gradient controller, and the solvent degassing. So mixing unit is used in a mixed solvent of different proportion and pass through the column. There are two types of mixing unit. They are low pressure mixing chamber, which uses helium for degassing solvent. Mixing the solvent is done either with a static mixer, which is packed with beads, or a dynamic mixture which use magnetic stirrer and operates under high pressure. And the gradient controller, you can see isoplatic separation. That is, it's very important. As I told, isocratic analysis and gradient amount of mobile phase, very important part. The isocratic separation of mobile phase is prepared by using pure solvent or mixture of solvent. Solvent, same eluting power of polarity used, but in gradient illusion. Taking the polarity of the solvent is gradiently increased by means of changing the proportion of the solvents which you are using as a mobile phase. Hence, the solvent composition has to be changed, and hence the gradient controller is used when two or more solvent pumps are used for separation. Understand? So solvent degassing is one of the component which is very important, and the solvent degassing of organic solvents, the pump and pump bubbles which is present will be interfere with the separation process. So this can be done as a very important process by vacuum filtration, helium purging, and ultrasonication can be done. So this also Madam might have done in the externally, she will be showing about that, how we can degassing, an instrument also having this degassing instrument is also fixed with the Hplc instrument itself. And injector, manual and auto injectors are there. Several types of injectors. Septum injectors which is also there, but it is not very commonly used. And stop the flow of the mobile phase and then injecting is also there. But rheodyne injector, which was very commonly present in the instrument, which we are even in our college, which we have the instrument, is also having rheodyne valve system. So rheodyne valve system, you might have seen, I have shown you. Personally, I took you and I shown you to see that there is a loop and there is a curved loop where 20 micro ml will be injected by means of syringe, and it will be, when you put the switch, when you make it 60 degrees down the knob, automatically it will be injected to the column for the separation. So the loading position and injecting positions are there in the knob, and turn the knob to 60 degree, and then immediately the injecting will take place, and which will be 0.1 to 1 ml, very small quantity, can also be injected with 10 to 20 micro ml, can also be injected as a sample which you are selecting. God column, as I told you, it is a column which is not getting separation of the compound is not taking place. It's only for contributes for it is just to remove the particulate matters or any type of impurities which may be present in the mobile solvent. And you can see analytical column is very important place where you are getting separated, decides efficacy of the separation. Several stationary phases available depending on upon the technique, and the separation used throughout the different columns can be used. Column materials, usually they are 5 to, column size varies from 5 to 30 centimeter, ranges from 2 to 3 millimeter of diameter, and the particle sizes also will be differ for each and every material which you are using. And the surface area we have already explained. So silanol group is usually hydroxy groups. When you want to make it more polarity, that is especially functional groups, reverse phase chromatography, they used to use for octodiol silane, 3C18, column of C8 and C4, and the butyl column, and the CN nitrile column, NH2 amino columns are also available. And other modes of chromatography like ion exchange chromatography, gel premium chromatography, chiral or sterol carbon column chromatography, and affinity chromatography can also be followed, and different columns are also available in that case. Detector, UV detector is very commonly used, which is for but there is other detectors like fluorimetry detectors only for fluorescence compounds can also be used, but UV detector is very common for everyone. And also refractive index detector, but it is not very efficient but still refractive, but cyanide by cyanide activity can also be used as a detector. Conductivity detector can also be used, and also ampermetric detector by means of can be also be used by means of proportional to the conducting of the compound. And this another one is photo diode. It is equivalent to array of same like detector, which is UV, and this detector can also be used for in 3D method can also be used. So detectors will differ, but in our instrument we are using UV visible detector, which can be I have shown you in the lab. And detector integrators are nowadays it is completely done by the computer, which you can get very detailed the peak area, and also peak values can be easily detected, and also we can find out the component getting separated. This is the video. Just see that lab of Dr. D.Y. Patel Institute Pharmaceutical Sciences of Research, how Dr. Sheetal P. Gandhi, she was explaining very amazing explanation. That's why I took even the lab was so well organized and well it is kept, and her explanation was so nice and so amazing explanation. So just listen to that, and even I will also let me refresh my small knowledge which I have. She has given a
Welcome to the second part of the video, demonstration of high performance liquid chromatography, HPLC. For practical demonstration, we will learn assay of paracetamol tablets by using RP-HPLC method. Instrument facility at Dr. D.Y. Patil Institute of Pharmaceutical Sciences and Research, Pimpri, Pune have quaternary gradient HPLC system of make Shimadzu. The system is equipped with LC software. HPLC analysis have various steps. First, mobile phase pre-treatment and preparation, standard and sample solution preparation, purging and washing, sample and standard analysis, and finally the detection. So we'll go one by one. So first is mobile phase preparation. Optimized mobile phase for paracetamol assay is 40% volume by volume of methanol and 60% volume by volume of double distilled water with 0.1% glacial acetic acid. So we'll transfer the methanol and water. Mobile phase pre-treatment is carried out before HPLC analysis and is performed by sonication and vacuum filtration. So we will now sonicate our solvents. This is an ultrasonic water bath with make as Bansar and capacity of 1.4 liters. Switch on the instrument. We'll set the temperature at ambient temperature and the timer for 5 minutes. Sonicate our solution to remove all the entraps. Preferred sonication time is from 3 to 5 minutes. We'll now move to the second step of vacuum filtration, for which we'll use vacuum filtration assembly. So here you can see the vacuum filtration assembly. We have a funnel where we can load our solvent and a reservoir where the filtered solvent is collected. In between these two, we have a connector where we will place our membrane filter. For filtration of solvent, we'll use 0.45 micron filters, and for filtration of sample, we'll use 0.22 micron filters. Now we'll place the membrane filter in the connector. And we'll filter our sonicated solvent. After sonication and vacuum filtration, our mobile phase is ready for analysis. Now we'll move with standard and sample solution filtration. Standard here is paracetamol pure drug powder. Weigh 10 mg of paracetamol powder and dissolve in suitable solvent. Here we have used mobile phase to dissolve the solvent to prepare a solution of 100 microgram per ml. This 100 microgram per ml standard solution is diluted to have working standard in the range of 5 to 50 microgram per ml. Working standards of 5 to 50 microgram per ml are prepared to form calibration curve of paracetamol. Now we'll prepare our sample solution. For assay of paracetamol, we'll use a paracetamol tablet with label claim 500 mg. We will weigh 20 tablets and calculate the average weight of the tablet. We'll then crush the tablet into fine powder and we'll take a powder equivalent quantity 200 mg of paracetamol and transfer into a 100 ml volumetric flask. We'll add sufficient mobile phase and sonicate the solution to dissolve maximum paracetamol in the solution. We'll then make the solution 200 ml and filter to obtain a solution of 1000 microgram per ml. We'll see the calculations for the sample preparation. Here you can see the calculations for sample preparation. So the label claim is each uncoated tablet contains paracetamol IP 500. We have weighed 20 tablets and this is the average weight of the tablet. We have calculated the weight equivalent to 100 mg of paracetamol, which is 121 mg. So now we'll move to the Hplc instrument. We'll switch on the instrument and the PC. Software with this Shimazu system is LC Solution. Double click the LC Solution icon on the PC. A window will open with LC Solution Launcher menu where various options in operation menu are real-time analysis, offline editing during the online operation and post-run analysis. For a new analysis, we'll click on Analysis 1. It will ask for user ID and password and then OK. The instrument will now connect with the software. This is real-time analysis window where we have data acquisition where the real-time analysis can be viewed. We have assistant bar where the commands can be given. Then we have instrument parameter view where the details of method analysis can be input, and the instrument monitor where the temporary change in mobile flow rate and the concentration of solvent can be given. To start with, we'll switch on the pump. We can give command to the instrument either directly through the display on the system or through the software. We'll operate our system through software. Here we can see the pump is on. As it's a quaternary gradient system, here we can see 4 suction filters labeled as A, B, C and D. Before we start with analysis, we need to purge the channels to remove the air bubbles through the tubings. For purging, the filters are dipped in distilled water and the purge valve is rotated anti-clockwise to open it. Now we'll give the command on the instrument monitor as 100% to purge filter C. We'll initiate the purge by clicking on this purge tab. Purging is carried out for 3 minutes at the flow rate of 8 ml per minute. Same way we can purge all the channels. Now we'll off the purge valve by rotating clockwise and we'll on the pump. Next step of analysis is washing, where again double distilled water is used. For washing is done for 30 minutes or based upon the previous analysis. To minimize the analysis time of HPLC, the pump are kept for washing and simultaneously preparation of mobile phase, standard and sample is done. Now we'll create a new method file. For giving inputs for new method file, we'll use instrument parameter view, where we have two tabs, normal and advanced. In normal, we'll select the pump mode as low pressure gradient. We'll give the pump flow rate as 1 ml per minute, and we'll give the concentration of B solvent as 60%. Automatically, it will take 40% for solvent A. We'll then switch to advanced settings, where in data acquisition we'll give the total run time of the analysis, the start time as 0 minutes and the end time as 10 minutes or based upon the analysis. Then in pump we have already give the inputs for flow rate and the concentration of solvents. We'll just give the input for pressure limit as maximum till 350 bar. Then we'll give the inputs for PDA detector, where we'll select D2 lamp for analysis. And finally, controller, where we'll take event 1 and event 2 as we are using 2 channels. After this settings in normal and advanced, we'll download our method file. The system will ask for a command to save the file, where it will ask for the path. We'll give the path for saving our file. We'll save the method file as para standard. Here the settings are saved and we can see here as para standard. With this settings, now we'll start with the baseline correction or column equilibration. We have already put our mobile phase and we'll just click on plot. So here we can see the baseline plotting has been started. Here we can view our straight line. Straight line indicates the column equilibration. Now the system is ready for our standard and sample injection. So we'll start with this single start. If we click on this single start on the assistant bar, a window will pop up as single run, where we need to give the inputs for file name and inputs for data file. We need to give the path where we need to save our data file. Once we give the input for sample name and data file, it will automatically take method file path and then we'll click OK. Once we click OK, the system will ask for sample injection. We'll use hypodermic syringe for sample injection. We'll fill the syringe with paracetamol working standard as 10 microgram per ml. Care should be taken to remove the air bubble through the syringe. And now we'll insert our syringe in sample injector. Once the sample is injected, we'll turn the knob from load to inject position. And the analysis will start. Here we can see the single start analysis has been initiated. This is the chromatogram obtained for the sample injection. Similar way we can do for all other standards and sample. Once the injections are done, we can analyze our data in post-run analysis. For post-run analysis, we'll again click on LC solution software. Now we'll go in post-run operation menu. This is the post-run analysis window where we can have a chromatogram view and the spectrum view for peak purity and peak profile. We'll open our saved data file. We give the path for the data file. I'll open one of the file which is previously analyzed. Here we can see the chromatogram for paracetamol standard 30 microgram per ml. Now we'll ask for display multi-chromatogram table where we'll give the input about the wavelength as 254 nanometer and then apply and click OK. To view the details of the chromatogram obtained, we'll go in View tab. In peak table, here we get the area and retention time of our sample. Here we'll also get the theoretical plate and tailing.
Thank you. And thank you, madam. And actually it was only one sample madam has taken, and she has the standard, and you have to take all the samples which you have prepared and then the same graphical area and the peak. These all the calculations can be done by means of the method. Calibration methods can be used by comparing with the standard. She was doing the same thing can be done for even for our herbal drug standardization. So the application of the HPLC, when we come across in the it was used in forensic, biochemical separations and biotechnology, food analysis and drug analysis and quantitative analysis for various formulation which we are now depending on this HPLC. Comparing with the standard is a procedure which we are following. And also impurities can be identified, and presence of impurities, and also impurities can be separated by means of even what type of impurities can be also identified, and also it can be percentage of impurities present can also be identified. And if you see quantitative analysis can be done, the madam have been even she was explaining about the how the direct comparison method can also be done, and also calibration curve method which you might have done, that is also possible, and also internal standard method is also possible for using this HPLC. So we can use calibration curve method is also possible, and also which can be done, that the madam was preferring for that, she was doing direct comparison method, and also internal standard method is also possible. And a multiple compound analysis determined for mixture of drugs, which is more applicable for in the herbal drugs, for a single multiple analysis and isolation of and identification of the drug metabolites from urine, plasma can also be applied.